In the previous video, we've mentioned MAC address, but we didn't really talk about it. We just seen that it's a physical address and that it's unique to every device. That's about it. Well, what about we elaborate on that next? Alright, let's do it. MAC stands for Media Access Control, and it's 48-bit long. That means it's 48 ones and zeros long, expressed as 12 hexadecimal digits. Are you wondering what is hexadecimal? Soon you'll want to know more. We already know binary, right? Let's start with the one that we know even better. Decimal. 0, 1, 2, 3, 4, all the way to 9, 10 numbers, hence the name decimal. And then we start using 2 digits for the number that follows. 10, 11, 12, 13, all the way to 99. Then 3 digits, 100, etc. That's what decimal is, and this is its order. The reason why we use decimal in our everyday life is because we have 10 fingers, and I kid you not. And then there is binary, which we refer to at some point as zeros and ones, 2 numbers, hence the name binary. If you want to list in order, it will go 0, 1, then you'll run out of numbers to use. You'll be forced to use 2 digits, 1, 0, which look like the 10 that we know, but it's not. The value of this is 2. Then it goes 1, 1, looks like our 11, but it's 3. Then we run out of numbers to use. Then we jump to 1, 0, 0, looks like our 100, but it's 4. And it carries on like that. So binary has 2 characters, and decimal got 10. Then here it comes the hexadecimal. The word hexa is Greek for 6, and decimal is 10, and as a whole it's 16. So 16 is the equivalent of 2 in binary and 10 in decimal, right? What does that mean? Well, it means a lot of things. One of them is that before we'll be forced to use 2 digits to represent the sequence, like 1, 0 in the binary and 10 in decimal. In hexadecimal, we'll have 16 single digits and then 2 digits. The first ones will be 0, 1, 2, 3 to 9, and to fill up this gap here, they decide to use the alphabet. A, B, C, D, E, F, and that's it. And then it comes 10, 11 to 19, and then 1A, 1B, etc. I think I need to move this one up here. So hexadecimal is from 0 to 9, A to F. The other letters are not included. There is a hacking scene in James Bond's scaffold where they thought they were. These right here are all hexadecimal values. The only real part of this scene, then they put this ground borrow spelled by characters that are not hexadecimal, just to fit in with this scenario. Not cool, people. Not cool at all. Anyway, the value of this 10 here is 16 in our language, and it's 1, 0, 0, 0, 0 in binary, 5 digits. Where were we before we got here? Oh, a MAC address. A MAC address is 48-bit long, expressed in 12 hexadecimal digits. Okay, here is a random 48 zeros and ones. If we dice them up into 12 pieces, 48 divided by 12 will end up with 4 bits per piece, right? Then we convert these pieces to hexadecimal one by one to get the MAC address. We can turn this into a table and use it for the conversion. I'll draw a line here because in the binary column it starts needing 5 digits to express values beyond that point. And we're only interested in 4 because of the math we've just did. So we don't need that bit. And fill up the rest using 4 bits in the binary column from 000 to 1111 in order. Oh, hold on. 1, 2, 3. Oh, 12 is missing here. Silly me. Sorry about that. I did wonder why those lines that I was drawing were not straight. Don't worry though, everything we did is still valid. So these values maps to each other horizontally. You'll probably come across the same table or slightly prettier one when studying on your material. Well, now we know where it comes from. Let's move this one to the upper deck. So this 0001 will become 1, and this 0101 is 5, and this 1110 right here is E, and you carry on doing the same to the other pieces. This is a conversion from binary to hexadecimal. If you're going from hexadecimal to binary, let's use my VMware adapter MAC address as an example, 0050 Part-6 C000020002. Right. By the way, this is how Windows represents a MAC address. It separates every 2 digits using a dash. There are other representations, like with colons instead of dashes, or separates every 4 digits with a period. It's same thing, different representation. So these are the 12 hexadecimal values. Therefore, each character in here is actually 4 binary bits. This single 0 right here is 4 zeros when computed, and this C here is 1100, and so on. So now it should be clear when we say MAC address is 48 bits long, expressed in 12 hexadecimal digits, and be able to perform binary hexadecimal conversion. There is another rule that must be followed here, and that is the first 24 bits identifies the vendor or the manufacturer. They actually need to buy it from the Institute of Electrical and Electronics Engineers. It's referred to as OUI, Organizationally Unique Identifier. Here are some of the well-known identifiers. Then the vendor assigns a unique value to the rightmost 24 bits per OUI. Overall, you'll get a unique MAC address per device. Now we have an idea regarding what is the MAC address. What we need to remember is that it's 48 bits long and represented in hexadecimal, which is 0 to 9 and A to F, in one of these ways, and that it's unique. I hope that you've enjoyed this. Don't forget to subscribe by clicking on that subscribe button, and stay tuned for more, and thank you for viewing.